Okay, well, yeah, welcome everybody to the Maths program info session. We will go ahead and start with our first segment. We have here Dr. Dunn, who is going to present some information on CSUSB's graduate program in mathematics. Dr. Dunn, if you would like to speak.
Sure. Thanks for having me here today. It's nice to see so many folks here that have an interest in the program. I think it's a good use of time to talk about it. For those of you that don't know me, I'm Corey Dunn. I'm a professor in the math department, and I'm also the coordinator of the graduate program here. It's a Master's of Arts degree, and what I do is I just help people. For those people that are in the program or aspire to be in the program, you would talk to me if you have any questions about the program. If you're interested in applying and you're not sure if you're a good match for the program, I could look at your transcripts to tell you how well you meet our prerequisites. When you're in the program, I do 100% of the. So if you have any questions about what courses to take or how to find a thesis advisor or anything, and then when it comes time for when you're getting close to graduating, I'm sure you'd come into my office for something at some point. So I'm really just the point person for everything that you would need as part of your graduate experience here. So I have Jeremy was good enough to supply me with a list of talking points that I wanted to sort of like go through to help everybody just get to know the program a little bit better. I think that's a good idea. I'm glad Jeremy did that because I think the number one thing that I kind of hear about and also fear at the same time are people that are really good matches for graduate study, but either don't know that they're a good match or don't know why you go to graduate school. And at the same time, you don't know what you even do there. What kind of math do you even study? I mean, I didn't when I was in college. I had to ask somebody. So we'll get into that. The first thing to talk about is just I want to give you an overview of the program structure and the curriculum. There's 31 units in the program. You have to take three required courses. Those are a communicating math course, which is a 2-unit course. I happen to be teaching that right now. It meets once a week, and it is 100% about how to communicate mathematics. That could be like writing a research paper. That could be help in how do you write your thesis. It could be how do you present mathematics? What are the things that what do you think about? How do you even get started in how to communicate? How do you even type math? So it's a lot of stuff to go over for just 2 units, but we make it work somehow. The other two courses that are required are graduate analysis and graduate algebra. And those are more or less continuations of the kinds of algebra and analysis you would have seen in the undergraduate program. That's a total of 10 units. And then you have to take 15 units worth of electives. And six of those 15, at least six, need to be at the 6,000 level or higher. Um, that could be at the 6,000 level or higher. We offer a topics course, a different topics course each term that can be repeated. A lot of people just take the topics course twice. Like I said, it's not the same course. It changes from term to term. We also offer a 6,000 level problem solving course. And then there are various other courses like a teaching practicum program course that is 2 units that people can repeat for credit. A lot of our TAs do that. And there's one or two other opportunities. The elective courses that are not at the 6,000 level, so maybe no more than nine, you could select from 5,000 level courses and or occasionally 4,000 level courses. You would talk to me if you have any questions about that. Um, at the end of the program, we have a culminating experience, which is you get to choose. You would either find an advisor and do a thesis, and that's the remaining 6 units, or you would enroll in one more elective course and take a set of comprehensive exams. I don't feel like getting into that too much because I think just getting you in the door is more important. How you finish the program is something you can talk to me later if you have questions. Of course, if you have any questions, I'm happy to answer anything. But those are the two options that you have to finish the program. So that's a good overview of the curriculum and the structure of the program. The next thing to discuss is just to talk about like what areas of focus the program has and any specializations of the faculty. We have a really, as I see a lot of familiar faces out there, so you already know this, but we have a large department that specializes in all manner of different types of mathematics. I specialize in differential geometry. We have people that specialize in abstract algebra. We have people that specialize in statistics or geometric group theory or applied mathematics or mathematics education. You know, basically any area of pure or applied mathematics or math education, there is probably more than one. Not only do we have faculty in that area, but we probably have more than one faculty in that area. So there's real I don't know where like I've never heard anybody like tell me, gee, I'd like to know more about the master's program, but it doesn't seem like you have enough faculty in the right areas. And it's like, well, actually, we do. So that comes up because it matters because of the way that you finish the program. The topics courses that are offered, we have various faculty that would teach courses in their specific disciplines. Or you could, if you just like statistics, then you could just track down one of the statistics professors that you get along with, and I'm sure there's a thesis that you could do in that area. Your advisor would help you to know just what makes a good thesis. But that's an important thing to mention, though, is that we have a lot of one of the things that I really want to like make sure everybody knows is that this program, and I've said this before, it's really for everybody. You know, like if you can meet the prerequisites, if you do well in your math major, you talk to me if you're not sure. But I mean, if you're in the program, there's a path for you that meets you where you are in your interests. I do have people that come to me and it's like, well, you know, I'd like to do another proof of the Pythagorean theorem. And it's like, well, I don't know if that's a thesis, but what you're talking about intersects with math history, and maybe you should talk to this person who does math history, you know? So there's really anything that you would want to do, we're here. And sure, other universities in the area might specialize in certain things that we don't outright specialize in. So I would understand if you wanted to do something specific in applied math and we don't have those. So like that, I mean that I would understand that, but for the most part, everybody finds what they're looking for here. And I think that's a real strength of our program. So moving on, the next point to talk about is about like the requirements for the programs and how you apply to the program. Uh, Really, what I can make this really simple is that I did first of all I designed the program because when we went to semesters, somebody had to do it and they asked me, and so I developed the prerequisites myself with also with Dr. Aiken. And we designed the prerequisites of the master's program to be the core courses in the bachelor's degree. So if you've done a bachelor's degree here and you've gotten a B or better in all your courses, I don't know of a way that you could possibly not qualify to get into the master's program. That's the way we've designed it. So like if that sounds like you don't even need to go to the website to see if you meet those prerequisites. But just for clarity, what you need is a B or better in an upper division course in abstract algebra, real analysis, a course in pure math, so like number theory or combinatorics or geometry, something in applied math like statistics, probability, differential equations, or some kind of numerical analysis, and then an advanced math course, so complex analysis, topology, differential geometry, advanced linear algebra. If you feel like you more or less meet those, but you're not sure, you ask me because it's possible that maybe there's a course you took that would count and you don't realize it. So I always encourage people to just ask. And if you meet those prerequisites, you also have to have a 3.0 or better. If you don't have a 3.0 or better, you should just ask me because there's a variety of ways to convince the school to still recommend that you be admitted. And I'm not being dishonest. What I mean is like, let's suppose that you got a C minus in yoga or something, and that you were just under a 3.0. Like, well, I could argue that you got a 3.0 or better in your math courses, and that's good enough, you know. If you don't have at least a 2.5, I would never see your application, just so you know. But anything above 2.5, if you're interested, you can always just apply and give it a try. You can email me ahead of time, talk it over with me, I could tell you what I think. One last thing about this is that, oh, and you also need some letters of recommendation and a personal statement, I think, for the application. Another thing, though, I wanted to mention is that if it's the case that you don't meet all five of those prerequisite categories, it is still possible that you could be admitted if you meet four of those. The specifics of that I can get into some other time, but there's a way that you could just be admitted and then take that last prerequisite as a student. So really, like the admissions criteria are pretty broad, um, and the only reason we've designed them that way is to make it's really a two-way street. We don't want to admit you if we don't think you're going to be successful, and those are the benchmarks for how we think you'd be successful. So if you have any questions about that, please let me know. Anyway, the application process, Jeremy, maybe you can help me with this, but I think you go to the Grad Studies website. Is that right?
Yes, yeah, as far as I'm aware, yes, yes, their full application form along with deadlines for, particular timelines for the year, yeah, should be able to be found through that site.
Are there any, do you know of any like programs for people to have their application fee waived?
Application fee waived. That is something that I'm not directly familiar with. It's something that I can definitely for anyone in attendance today, that's something I can look into a bit more and perhaps provide in the future if anyone would like to contact me in the future. Let me actually put in the chat just for everyone who is in attendance, for anyone who might want any follow-up information. I will go ahead and put my email in the chat so you can contact me for yeah, discussing things like looking into waiving application fees and things of that nature.
Cool. Thank you. Yeah, I know that some people can get their fees waived if they ask. I don't know how that goes. I actually don't have anything to do with that, although I do get questions about it. So thank you for being available to answer those if anybody had any questions.
Oh, of course, and thank you so much for bringing that up.
Yeah, it's a big deal. You apply to four different graduate schools. If it's $50 each, that's $200, so that's some quick math. All right. The next thing to talk about is just any important dates or deadlines. I think I, anyway, the official answer is that if you want to apply for like spring is probably too late according to the website, but if you apply, but not too late for fall. Um, I don't know what the deadlines are. I think it's probably halfway through the semester before, but that doesn't mean you can't reach out to me. Like you have this meeting with me right now, and then you realize, gee, I didn't realize that I qualified for master's study. I'm interested now. I wish I could go in I wish I could start in January in the spring semester. You probably still can. Like if you're late, if you miss a deadline for admissions, I mean, you could always just call the office and say, "Hey, I'd really like to apply. Is that okay?" I've done some really crazy stuff. I've been the graduate coordinator for 15 years. I've done some crazy stuff trying to get people admitted. So don't worry about, I mean, I think you should try to meet the deadlines because that's the only way you could really be sure to be considered. But if you miss a deadline and you're interested, you just reach out to me or reach out to Grad Studies. There's probably a way to make it work out. I'm trying to make you get the impression that you should just do it and not be held up on any concerns that you have that are administrative like that. You should just do it if you want, if you want. The last thing that's on my list before I put something in the chat that's more information is about financial aid and scholarship options. This is something that I have tried to work on as anyway, I don't want to tell you how frustrated I've been by failure, but there are not really very many other options for funding here at Cal State San Bernardino that are beyond the normal financial aid options with the school. Because with the school, you could qualify for financial aid, you do a FAFSA, all that kind of stuff. That applies to graduates as well. I will say that some grants or scholarships or loans or whatever require you to be a full-time student. The definition of full-time is different for graduate study. I think it's like 6 units of graduate study is full-time. Jeremy, I don't know if you know the answer to that, but
I have to do I have to do a little looking into it. It varies a bit for each master's program within our at
okay.
CSUSB. But
Yeah, so I mean, like, you don't need to feel overwhelmed. I think that I think it's a general rule that you can get take less units and still be considered full-time if you're a graduate student. There are a couple of opportunities that are different from those that are advertised. The first and the biggest one is the Graduate Equity Fellowship Grant. And I'm going to put a link in the chat. I just can't do two things at once. So I'm going to put a link for it in there. A Graduate Equity Fellowship is there's a pool of money. I don't know how much it is. It changes sometimes from year to year. But it's for people that are in need, and it's a straight scholarship. It's free money. And there's an application, I think, on the Graduate Studies website. I'll put the link down. And that sum of money is split amongst the people who are eligible. I think it's at least $500 for the year, but it could be as much as $2,000. So that's one thing, and I don't think it's well known. So I want to encourage people to apply for that because I mean, it's free money. The other funding opportunity is not as obvious. I mean, the other one, there is an application procedure. It's not clear if you would get it. It depends on a certain set of factors. Sure. But we also have a TA program. And this is common in math graduate programs. We have a variety of different courses that we need taught at the lower division level, about the 1,000 level. I'm thinking specifically of pre-calculus, and like we have 1402, 1201, those kinds of courses. There are occasionally some need for graduate students to teach other courses when those needs arise. But we hire each spring some number of students, depending on how many courses we need covered, and you teach your own class. And I see a hand up. Ashley, do you have a question?
Yeah, do you have to be in a do you have to be in the teaching program to do the TA work, or you can just be, because I'm an applied math major, so I just want to know, do I have to be in the teaching part to do that?
No, you don't. That's a great question. And just to be clear, I think I know what you mean, like teaching track, like as an undergraduate. If you would have graduate standing, we don't have different tracks. So we don't distinguish people in tracks based on their mathematical interests. And it's the same degree anyway. And so, no, the only qualifications to be a TA is that you need to be a mathematics graduate student a classified graduate student in good standing. Classified means you have no more prerequisites to take. Like I said earlier, if you don't have one of those prerequisites, you can still get admitted, but you can't be a TA if that's the case, until you resolve that prerequisite. And being good academic standing is basically my judgment. If you don't have a 3.0 or better, I would say you're not in good enough standing to start being a TA. But if you get hired as a TA, then it's expected that you would be able to continue as a TA unless things really go wrong. So anyway, I hope that answers your question at least. So
Yeah, thank you.
yeah. I think we hire in the past, we've hired anywhere from 4 to 8 or 9 graduate students. So these can be fairly competitive. And I get a lot of emails. I get a lot of emails from people maybe from across the country, and they want to know, can they get funding? And I tell them the same thing about the Graduate Equity Fellowship, but I think it's the case that at PhD granting institutions, the impression that I get is that if you are going to get into that program, they have a funding spot for you. And I don't think that people understand that about Cal State San Bernardino, that while we have a TA program, it's not guaranteed that if you get in, or expected that if you get in, that you'd have a spot for it to be a TA. So we go through an interview process in the spring. It's advertised around Jack Brown. And then I do interviews along with Dr. Marsh. And then we make recommendations to the department chair about how that works. But you teach your own course. It is not like you're in running a lab or something like that. You are the instructor of record and you get paid as an employee. I don't know how much you get paid. I get that question too. And I'm really glad that I don't know because I can just tell people to ask the department chair. So I don't, but there's benefits. I even think there's a TA union. There's a lot of great stuff about being a TA. Not to mention the expertise that you gain and the experience that you gain by doing such a thing. So those are the options for financial aid. It's either the standard financial aid, graduate equity fellowship, or to this TA program. There's nothing to do with it now. I would say that if you're interested, I would look around for the posted things that come up in the early spring, or to ask me or Dalton when it gets closer. So that was pretty much my spiel. Jeremy, I'm going to hand it back to you and try to put those links into the chat. Maybe you could tell us what's next.
Yeah, of course. And thank you so much, Dr. Dunn. Yeah, a lot of good information in there. And thank you, Ashley, for your question. Yeah, definitely anyone else who may have questions coming up, yeah, definitely feel free to keep those in mind for our Q&A segment coming up in just a bit. I just want, we will move on to our next segment. I do want to urge, I am going to ask my co-host, DeAndre, to put our link for Science Success Center students to log their attendance again, just because I have seen just some instability with certain people's connections. So I want to make sure that in case anyone might have missed it earlier, that they have a chance to use that link. So yeah, go ahead and look for that in the chat. We should be able to repost that again for you guys soon. Yeah, we will go into our next segment in which I am going to not quite expand on topics that Dr. Dunn has mentioned, but I would like to give just some more general, less specific information about just finding grad programs that work for you, considerations to make for find ones that align with your interests and things of that sort. So let me go ahead and share my screen. Okay, and hopefully everyone can see this okay. But yeah, so I'm just going to go through very brief presentation on just some important factors that you might want to consider for finding a grad program that works for you, whether it happens to be at CSUSB or at another college program that you may be considering, and whether it's a master's or a PhD program that you might be considering. In my view, there's kind of three main points that you could consider for determining, finding a grad program that really works for you in the long term. The first is setting your long-term goals, figuring out exactly what it is you are looking for yourself. The second is networking, making connections in your chosen field that would be most beneficial to you. And third, the actual application process and getting ready for those specific things to start getting prepared for. So in terms of setting long-term goals, there's two kind of overarching considerations that can be helpful to think about. So the first is asking yourself, what do I want a grad program to do for me? What do I actually want to get out of a program that I might be considering? So there's a few big questions that you could start asking yourself, to be ready for that. So there's what do I want my future career to look like? This applies to a lot of things. From your values to what do I what kind of impact do I want to be making on my industry or on my life by going into a certain career field. It can look like, what kind of work-life balance do I want to be considering? Do I want there to be travel involved with my work, or do I want to be find a more stable position for long-term and have go for a degree that more aligns with making that happen for myself. Taking that in consideration can be important. There's what areas of study am I interested in? Dr. Dunn mentioned a lot of the things that CSUSB offers in terms of areas of study, but figuring that out for yourself, like which areas really matter to you and are something that you would want to invest more time in personally and for your career interests. And striking a good balance of personal interests versus applicability and marketability in your chosen career field down the line. Some important things to consider. And you could also think about how much flexibility do you want in your chosen path. It's very rare that the choices that we make setting out in starting our education end up being like exactly where we end up near the end of our career down the path. There's always a lot of possibility to make adjustments in exactly what kind of career field we want to go into, what kind of research we want to be doing, and things of that nature. So figuring out for yourself like how much flexibility you want built into plans you want to make for yourself can have a lot of value. or at least to, question for yourself how much you want to consider that. For all of these, and also for the second major consideration that I'll go into on our next slide, using something like an individual development plan can be a really helpful tool for figuring these out for yourself. It also really apply for a couple different points I'll make a little bit later in the presentation. But an individual development plan or tools like it are really handy for helping you, state down in really solid language what you want your long-term goals to be, what skills you want to be developing to make those goals happen, and things of that sort. So that is asking yourself what you would want a grad program to do for you. And there's kind of the flip side of that. What would you be willing to do for a grad program? So there's a lot. This factors into a lot of the practical considerations of choosing a grad program. So it's things like how much are you willing to pay or earn during this program? As Dr. Dunn mentioned, for CSUSB's program, there's different funding and scholarship options for here specifically. But depending on other grad programs you might consider, there can be options for again all TA positions for different labs to help pay for your program. And as he mentioned, a lot of PhD programs, as opposed to being something that you often pay for in terms of a master's program, PhD programs tend to include the funding as part of the being accepted into them in the first place. Along with this, there are certain pathways for certain career fields where if you put in time with a given company, depending on the exact pathway that you're following, they may be willing to pay for your master's degree in order to further your ability to progress in your current position. So those are all different considerations to make in terms of that, how much you are, willing to pay and earn, or else, devote time into for different programs. There's how long are you willing to spend in this program? So timing wise, for how long master's and PhD programs can take, as kind of an average, master's programs tend to last around 2 years, while PhD programs are a bit longer, more in the 3 to 5 year range. So it can be important to ask yourself relatively how much time you would want to spend in the program versus just how useful you think it will be to you in the long term. And there's also, do you want to approach this as a full or part-time student? Depending on your program, there will be options for either approaching the program as treating it as a full-time position, putting 40 or so hours into it per week between classes involved and TA or other positions that might be involved with the program, versus something that you can do alongside other work that you might be doing to sustain yourself as you pursue your degree. So those are all important questions to ask yourself about how much investment you would want to put into whichever grad program you happen to choose. So that is the goal setting portion. The next big section that I have is networking. So again, I have two big kind of segments that I think are important to consider for the networking aspect of preparing for grad school. How do I find professors or labs that align with your goals? So figuring out those goals in the first place, what you want to get out of your program and what you're willing to do for your program are important to, being able to make these considerations. But once you have figured those things out, this will look a lot like getting involved with research and internships during your undergrad that help you explore your current interests. Your undergrad is a great point in time to start figuring out exactly what you like or don't like about mathematics as a field, and figure out exactly which direction you might want to go into within that field, and find those opportunities within your undergrad while you're still here can be super helpful for helping you make those determinations. Getting to know professors in your program, something that I tend to recommend to students that I counsel all the time. Getting to know professors, personally, be able to feel comfortable in going to them for recommendations for, within program at this school or for other programs that they might be familiar with at other colleges, can be a super helpful way to be exposed to information that may be useful to you down the line. And there's attending conferences. Conferences are one of the best ways you can network with other students and professors outside of CSUSB. Making those little connections that help you just have different points of contact to reach out to help figure out things like, specific pieces of advice that, might not be clear to anyone as outside of like the really specific set of situations that you're looking to make happen for your specific goals. So yeah, if you gain the chance to attend a conference, whether you have research to present or just observing, can be a really handy thing. One thing that I tend to recommend a lot for students, if they haven't used it up to now, the Office of Student Research can be a really helpful way to know what research opportunities are available on campus, and also different funding that's available to help with things like attending conferences or things of that nature to kind of make that more available to students who would like to pursue that. So as for kind of the second big aspect of networking is how do I prepare for making needed connections? A lot of this comes down to just practicing how to kind of socialize and connect with people within your chosen career field. So practicing that now in a few different ways can be really handy. Joining clubs related to your major or general interests, just having, taking on responsibilities related to your major, getting to know people who are related to it, can help a lot in, figuring out how exactly to, it's really good practice on the peer-to-peer level of making those connections that can really be applicable to connecting with, professors or students from other colleges down the line. Again, getting to know professors in your program or at conferences, kind of the next kind of step up from that, being able to have those kind of connections that you can rely on and make in the future. And you also try to make a social organization or hobby. Pursuing something like Toastmasters, as I mentioned at the bottom, it can be a really helpful resource for practicing things that can come up really easily in different conference-related settings, things like poster presentations, speaking arrangements, things of that sort. It's never too early to start practicing for networking and getting ready to make connections that will be really important for your future career direction. And then the last thing I want to cover is just the application process. Dr. Dunn already covered a lot that, aspects of, some of the application and structure for CSUSB's program that really applies to a lot of other program requirements for application. But just to kind of review some of the most common things that can come up, some common prerequisites, things like standardized testing and GPA requirements. Standardized testing is a little less common these days. A lot of colleges are moving away from it a bit, but certain tests like the GRE can still be something that can be asked for by certain programs. So it can be good to check for any specific programs you might be considering to see if they, which testing, if any, they might prefer that you have on your record. Getting ready for being able to present a cover letter or personal statement. As Dr. Dunn mentioned, personal statements can, as well as letters of recommendation, which is mentioned in my next bullet, come up fairly often in application processes. No matter where you go, you'll probably have to have something of that sort prepared. So having something like that worked on ahead of time, which comes down a lot to just practicing your own personal writing style and reflecting on, your personal goals, helps a lot in making that writing that personal statement a lot easier. So the earlier you can start on that, the better. And letters of recommendation. Oh yes, Dr. Dunn.
Thanks. I'm really sorry to interrupt, but I just had to mention that when you said about GREs and some other testing, that's something I neglected to mention, that Cal State doesn't require you to take any exams like that. I think that if you're an international student, you might have to prove English proficiency with a test like that. I forget what it's called, the TOEFL exam or something, but we don't require either the general or the math GRE. In fact, you were right to point out the GRE, But it's my and although it's my understanding that various graduate schools are questioning whether or not they're going to use the GRE on a large scale. So when you said that you should research whether or not people are going to require the GRE, perhaps at another graduate school, I don't know why you wouldn't go to Cal State San Bernardino, but that's a really good point that that you should find out if they do, because 20 years ago it was expected that you needed to, and that's not the case as much. And I'm not sure the landscape is changing. So I just wanted to point that out before you got too far away from it.
Oh yeah, no, definitely. Yeah, thank you so much for your for contributing that. Yeah, I know at least personally for my program, I'm actually currently a master's student in our biology program at CSUSB, and we actually we moved away from using the GRE very soon after I joined the program. So it's definitely something that's been changing a lot. So yeah, definitely can help to just look into if you if it's really something that's required in your specific case or not. And then finally, a letter's recommendation. Again, Dr. Dunn already got into these, but yeah, it can help to have. It can always be helpful to again during your undergrad if you're able to connect more with certain professors from your classes, professors that can comment on your personal ability during their classes. That can help a lot in preparing for things that come down the line, either with that or with any volunteer related or internship work of that nature, or in research. Okay, and then the final point that I want to focus on is just how to be a strong applicant. So just different ways to raise your likelihood of being more competitive for programs in general. Probably the top thing that can be recommended is trying to get into research and internships. No matter what field you happen to go into down the line, having some sort of experience is really useful in a variety of contexts. So I definitely encourage if you're able to find opportunities of that sort, try to chase after them. Finding classes that align with your chosen research or career direction. As Dr. Dunn mentioned, there's specific courses that our program asks for as given prerequisites, but based on programs that you might consider, there might be other courses or that might be aligned more strongly with a particular direction that you would want to go in. So being able to find that out as early as possible and kind of gravitate towards those classes that might be more generally useful to you could be a good approach. And of course, maintaining a strong GPA, as Dr. Dunn mentioned, that can be a strong factor for having above a certain baseline in order to be considered for the application process. I also tend to recommend, if certain things like your GPA isn't quite where you were hoping it to be for, graduate work, you do always have the option of pursuing a more post-bac related courses, courses that you could pursue after your graduate or after your undergraduate degree, just to improve your GPA and improve your likelihood of getting into programs in the future. And you also consider things like certificate programs that could help with certain aspects of a career if you aren't able to pursue master's studies right away. Those are all the things that I feel are important to mention as just general useful things to consider. I kind of just have a full summary of all the different points of the things that I've gone over just for easy reference. So that is that for that segment of our presentation. From here, we will go ahead and go into our final segment, which is kind of our Q&A segment. So for this portion of the presentation, I will go ahead and leave it up for just a second in case anyone would like to, just have this page for reference. But as we move into this, I want to encourage, we have certain questions that I'd like to pose to Dr. Dunn just we're in our program. But I also want to leave it very open for anyone in the audience to ask any questions that they might have been thinking about or want to prepare or bring up prior to this. Let's see, I believe. So anyone in the audience, you are more than welcome at this point. I'll leave it open right now for if anyone would like to unmute their mic and ask a question, or would be preferable if you use the raise hand function. That can be a useful way to let us know that you'd like to speak. If not, you can also use the chat function if you would like to ask any questions you may have.
Jeremy, while people are thinking about their questions, can I just mention one more thing?
Oh, of course, go ahead.
I get a lot. I'm doing a special like deep dive this year into this, but I wanted to mention that there are a lot of careers that people can get with a math degree. And I mean any math degree. And a lot of those degrees, and it's funny because I was, like I said, I'm looking at this year very carefully. In fact, anyway, I don't, that's a whole nother story. But I'm very interested in that because people say, oh, what can you do with a math degree? Like, you can teach with a math degree, you can teach math, and there's a real need for really good math teachers. So that's a really good career option if you like teaching or if you want to go into that. But there's actually a lot of other ones. And instead of telling you about the ones that I've sort of been looking into recently that are available for graduates, I'll just tell you that the kinds of prerequisites that I saw, qualifications for these jobs, it would say degree in, computer science or mathematics or a related fields. I think computer science is just one example, or whatever the field is. It seems like if you have a math degree, that's like a wild card in any field that requires quantitative ability. So, for example, I went to the Esri open house that they had there in, I guess it was in October. And I learned a lot about the different kinds of careers that are there. And I actually was curious. They have internships as an example. What are the qualifications for that? And sure enough, it says mathematics is a degree that would qualify you for those jobs. So I think that in different industries, it relies on your mathematical abilities in different ways. So I just list a few of those industries instead. There's the NSA you could work for. One of my last graduate students went on to work at the NSA. She had an internship and then was hired. You could work for NASA. You could work as an insurance adjuster. Those are people that rely on statistical analysis to inform the company about how much to charge for stuff. Um, you could be a financial analyst. Those people make tons of money. Um, like I'm kind of wondering why I'm not a financial analyst if I was interested in making that much money. Um, all of these different, I mean, anyway, there's a lot of other ones, but a lot of them too involve programming. Machine learning is an example of an intersection between mathematics and computer science. A lot of companies really want data analysts to study data that they collect and inform the company about the trends of their customers. Advertising agencies, so like a lot of stuff in pure math, there's a lot of stuff in applied math, there's a lot of stuff in data science, statistics, math education, teaching. Or you could simply go on to graduate school, get a PhD in math. That would better qualify you for these things and give you a raise if you had a higher degree, either a higher degree being a master's degree or a PhD. But I'm thinking when you're done with the MA program, you could go on and get a PhD and you could do all of those things, but you would qualify at a higher rate. So I really truly believe that a math degree, whether it's a bachelor's degree, maybe I'm preaching to the choir here, but a master's degree or a PhD, those are like some of the most sought after degrees in terms of qualifications in a lot of different industries. And if you catch me at the end of the year, I'll have even more specific information about that. But those careers. But I just wanted to get people like I think some people are like, I don't know, do you want me to just sit through classes for 2 years? And it's like, well, maybe. But I mean, I think a lot of people come into graduate school. Some of them come in thinking that. That's what I did when I went to graduate school. I'm like, I don't know. I want to go to grad school. But other people might want to have a career in mind, and those are some examples of careers you might consider, and that a math degree would really help you with. So, just wanted to point that out. Maybe that gives people some more questions.
Yeah, thank you so much, Dr. Dunn. Yeah, I think it's so valuable to, let students know that there's, so much more to think about and like that's possible for the future than might be immediately apparent just based on, the information that they're exposed to. Like, especially for you mentioned Esri, they actually have their main campus just so close to, our neck of the woods, just over in Redlands. Yeah, they're for anyone not aware, really cool mapping software related organization. Um, uh, but yeah, thank you so much for sharing that, Dr. Dunn. But yeah, again, so if there are any questions, yeah, feel free to use the raise hand function in the chat. I'll give it just a second to see if anyone has anything either there or in the in our written chat.
You must have done a really good job, Jeremy.
Same to you. Let's see. In that case, I might move to some of our prepared questions. Well, actually, I'm curious about this because I think it's a fun thing to bring up for especially undergrad students. Not quite one of our prepared questions I read ahead of time. What would you say is the kind of difference between the 4,000 and 5,000 level courses that students might be familiar with versus the 6,000 levels that grad students tend to take on in your program?
That's a really good question. And I think I can answer a more broad question, which is the way that maybe just graduate education in general is different from undergraduate education. I think undergraduate education, you start, and I mean, I went to college. I remember, like I took all these classes, you show up, your teacher asks you to do things. I think at least here, I don't know about other places. I mean, when I went to graduate school, I'd say the same, but I think here I've made a point to make sure that this program is for everybody. We have professors that care. All of you probably know this already, but the professors really care about what they're doing. They are deeply knowledgeable in what they're teaching. And I think that when it comes to a graduate course, there's a mixture of being a little bit harder, like maybe a little bit more complicated mathematics, yes. Maybe it goes at a pace which is a bit faster, yes. But you also have generally professors that are very understanding, that want to get the math across to you and just care deeply about that. So what's now more specifically, what's the difference between a 4 or 5,000 level course and a 6,000 level course? Is that there's a couple differences. I would say, like I had mentioned, the 6,000 level courses are a bit deeper and it's more expected that you'd be able to keep up. If that frightens you, I hope it doesn't. But because, people say, I don't know if I'm ready for graduate analysis. And I say, did you take the prerequisites? The answer is yes, you're ready for it. That this course is not easy. It's not going to be easy. It's not going to be any easier. You just have to take it. And you're in a class with a group of people that are also concerned that maybe they're not going to do well. We have a good community of graduate students here. I think that the 4,000, 5,000 level courses can be populated by undergraduates. It's just a little bit less. It's not, I mean, it varies, depends on the teacher, really. But the level of expectation, I think, is just a little bit less for those courses. So I would say, like, when I look at graduate applications, one of the things that crosses my mind is whether or not this person, looking at their letters of recommendation, their personal statement, is this person ready for graduate study? And the answer to that question, I judge by whether or not they have a healthy fear of, of the graduate courses that they're going to take, because they aren't easy. But that's not a reason not to do it. We have prerequisites for those courses for a reason. And I consistently tell people, if you meet the prerequisites for the courses, we have designed that course so that you should be ready for it. So take it. So I would say, like, yeah, it's a good question. What's the difference between them? But I wouldn't fixate on that difference. I would just take the course.
Okay, thank you so much, Dr. Dunn. Let's see, we are just about out of time. I do want to open this up one more time, just any audience questions at all that that might be handy. So I'll give just a second. If not, we'll maybe conclude with just one more brief question. Uh, okay, so we'll go ahead and conclude with yeah, just one more brief question. Dr. Yeah, we've already touched on a lot of what some of our prepared questions would have touched on anyway, but I think I'll go ahead and with one of our last ones. What can an undergraduate do now to start preparing for grad school? I talked about this quite a lot from a general perspective, but in your view, what would be that approach?
I think there's a couple things I would suggest. The first thing I would suggest is more broad, and that's to focus on what you want out of grad school. Why would you go? See if you can answer that for yourself. For me, and just to be clear, an acceptable answer is I don't know, I just want to go to grad school, because that's what I did. I decided that my identity as a mathematician when I was younger, I'd really be cheating myself if I didn't try. I know that's not the way everybody feels, but that's how I felt. So ask yourself, why do you want to go? What are you going to get out of it? Are you ready for graduate study? Are you ready to make a commitment to, pour a lot of time into these classes? And I don't mean pour a lot of time as like your life's going to be wasted for 2 years. What I mean is that you're going to get, this is one of those programs where you will get as much out of it as you put into it. So, for example, if you want to learn enough mathematics to go because you've decided you want to go eventually get a PhD, then you might try to take more difficult courses now. And when you're a graduate student, you might choose electives or a certain path for your thesis or something that sort of like helps you meet that goal. So, step one, decide what your goals are and why you'd want to go to graduate school. The second thing I would do is to not allow yourself, this is hard, but not allow yourself to be intimidated by the prospect of going. This place, people wonder what's it like? What's it like in graduate school? It's, I don't want to say it's like undergraduate because it's definitely different, but you do the same stuff. You go to class, you try hard, you have homework, you'll do a thesis. That's scary, but you come talk to me. I'll help you, find a thesis advisor. I advise theses too. Just don't be intimidated by it. And I think the best thing, maybe as a closing observation about that, is I had a student in my office, that chair right there, right behind my computer. And she was like, I don't know if I'm really like good for graduate study. I mean, I don't know if I'm smart enough. And this was somebody who came from a first generation, she was first generation college student. And I looked at her and I said, "Can you remind me what I knew this, but I said, "Can you remind me what your GPA is?" She said, "Well, it's a 3.97." And I said, "You listen to me. What else would convince you that you are ready for graduate school? What else? What would you need?" And I didn't say it like that. I was very kind, but I mean, people think that it's this insurmountable thing. It's not. People do it all the time. And if you have a question about whether or not you are ready, you're afraid of failing, I get it. But if you meet those prerequisites to the program, or even almost meet those prerequisites, and you meet the prerequisites for the various courses that you need to take, you're ready for this program. And if you're not sure, then you can just sit in that chair and be the next person that I raise my hands up and say, what else do you need to know that you're ready for graduate study? I think that's one of the things that really turns people off and it paralyzes them into indecision. And I'm just saying, don't let it paralyze you. You have a transcript. Do you have a 3.0 or better? Have you taken these courses? Then you're ready. End of story. The only question is whether or not you want to come. Do you want to put in the effort? Do you want to get this degree? If the answer is no to that, don't come. But like if you want the degree and you're just hung up, you're paralyzed into indecision because you're not sure about it, I'd be happy to have that conversation with you personally. you already know how it's going to go. And it's going to end with me suggesting that you apply. And so the last thing I want to mention is just a couple of you I know in here, but I mean, and you already know this, but I mean, my office, it's a really nice place to just stop by. You chat with me. You have any questions? You have any concerns? That's what it's like to be a grad student. You're taken care of. I take care of you. I make sure that you're doing the right stuff. I can direct you to the right resources. It's not a one and done kind of thing. I mean, like I really care about everybody in the program, and I want to make sure it's right for you. So please, if you have any questions or interest, you stop by, send me an email. Be happy to talk it over with you.
Thank you so much, Dr. Dunn. Yeah, so much good encouragement in there. Yeah, I think, yeah, finding that, will in yourself to pursue that, I think that can be so valuable. So yes, thank you so much for, yeah, putting it out there for the students. So yeah, with that, we are just about out of time. So we'll go ahead and conclude our meeting. But thank you so much for everyone in attendance. Thank you so much, Dr. Dunn, for all the insights and perspective that you have given us today. Yeah, again, I'll go ahead and put in chat. Again, my co-host DeAndre will put in the chat our attendance link just for last second. If anyone from the Science Success Center has not filled out their attendance link, please go ahead and do so. I will go ahead and once again put my email in the chat if anyone would like to reach out about waiving grad program application fees and things of that sort that I can look into them. Feel free to contact me about that. And Dr. Dunn's email as well, I believe, is in the chat. Yeah, again, thank you everybody for being in attendance. And thank you, Dr. Dunn. I hope everyone has a good day.
You're welcome. Thank you. Bye-bye.
Goodbye.